So the good news is that none of this should be new, okay? It should be review, which means I'm going to go a little bit faster paced than typical, okay? We got a lot of notes to get through in today, and it's a little bit shorter. So today we're going to talk about two forms of solving systems of linear equations, substitution and graphing, and then we're going to get into some of the like real-world application of that stuff. And then tomorrow's section, or 7.2, is elimination. By the time you get to like a quiz or a test on this, you might just see the word solve, and you get to choose which of those methods you choose, okay? Specifically for graphing, you'll probably be asked to graph, because otherwise no one would choose that one, probably. But until we get there, pay attention to directions. If it says solve using graphing, you want to graph. If it says solve using substitution, you want to use substitution. God bless you. And if it just says solve, then you get the choice, okay? So what is a system of linear equations? This is two linear equations in which you have two variables. So this is linear being both lines, right? Two variables, and both of them would be raised to the first power. And the solution to a system of linear equation is an ordered pair that satisfies both equations in the systems. So when you get to an answer and you wanted to check it, it would need to get plugged into both equations in order for it to work, which is the first kind of problem. So it just says to determine if the ordered pair -1, 3 is a solution to the system. So how do we check that? Plug it in. Good. And it's got to, again, it's got to work for both. So the first one, x and then y, and take it and plug it in. 2 times -1 minus 3 equals -5. -2 minus 3 is -5, which equals -5. So it works for the first one. And then plug it into the second one. -1 plus 3 equals 2. And 2 equals 2, so it works for the second one. So this is a simple yes or no, and in this case it's yes because it works for both. So because of this, every single question can be checked. Every answer that you get can be checked in your initial system, and which also leads to you will probably not very likely see multiple choice here because you could just take them and plug them in. However, if it's multiple choice on a standardized question, right, standardized test, take them and plug them back in. If it works for both, then you've got your solution. All right, so this is how you can find it from a graph. If you're looking at a graph of two lines, actually it doesn't have to be two lines, it could be a nonlinear system too. The graph of anything, where they intersect is the solution of them. So these are going to be in x, y values, not all like on a graph obviously. You can also see variables as a and b and m and n and q and r. When they're listed in your ordered pair, which is what your answers will look like, you always go alphabetical order. So if you had A and B, then A comes first, B comes second. Obviously, we know X and Y. X comes first and Y comes second, okay? But in this case here, this point would be the solution because it's where they intersect, and that would get labeled as 4, -1, and that's how you'll rate your answer, ordered pair, X, and then Y. So solving using substitution. This is the first method we're going to review. So you're going to have two equations, two variables. You're going to pick one of those equations to solve for one of the variables, and it doesn't matter which one, whatever's easiest. You're going to take the expression that you just solved for and plug it into the other equation, into that variable. Once you simplify that, you'll only have one variable. You'll solve for it, and then you take that and plug it back into either of the initial equations to get your second value. So there are special cases when you're dealing with substitution and graphing and linear, okay? And elimination, which are your no solution and your all real numbers cases. If your variables cancel out, so you lose both the x and the y, and what's left is a true statement, like 0 equals 0 or 3 equals 3. Obviously, these are true statements. Then your answer is all real numbers. And you can either write out the words all real numbers, or you can give me that like fancier R, just like an R with an extra line. If what's left is a false statement, like 0 equals 1, or 3 equals 5, or 7 equals 8, something like that, then it's no solution. So this is going to happen with substitution, and you'll see it with elimination too. There are special cases with graphing, but you just find them a little bit differently. So your answer will either be an XY combination in ordered pair format, or it will be all real numbers or no solution. All right, so example 2, solve by substitution. So I'm going to look at these two equations, and I'm going to try to figure out which one would be easier to solve for either variable. So pick an equation, pick a variable, try to plan it out ahead of time so you don't just start going off the first one, because it might be easier to do the second, okay? So if you look at both of these, which would you want to solve for, and what variable would you solve?
The first one for y.
Okay, so pick first one for y. That would be most of you, yes? Because the second one, the x is almost by itself, but you'd still have to multiply by a negative to get rid of it. So if I take this first one and I solve for y, I get y equals 9 minus 5x. Now I've used the first one, so I can't use that one anymore. I'm going to take what y equals and plug it into the second one. And I get negative x plus 3 times 9 minus 5x equals 11. Negative x plus 27 minus 15x equals 11. Negative 16x equals negative 16, and x equals 1. So halfway there. Now I'm going to take that and plug it back in, and this is where your options come back into play. You can take that 1 and plug it back into either of the original equations, or probably the best bet is plug it back into the one you already solved for y, because that's what you want to find in the end anyways. So if I take that 1 and plug it back in there, I get y equals 9 minus 5 times 1, y equals 9 minus 5, and y equals 4. And then my answer goes in ordered pair format. So 1, 4, in parentheses, just like that. Nick?
Like on the test or quiz, we only have a choice between substitution.
So I said you're going to have probably somewhere it gives you exactly which one you have to use, and then somewhere you get a choice. By the time test comes around, it will probably be graphing or either of the other two, because they kind of hold equal weight. My advice is to get familiar with both when we get to elimination, because sometimes it's easier to do elimination, sometimes it's easier to do substitution. So you want to go into it being able to do both, because depending on what you're given and the format of it, it's going to be easier to do one or the other. All right, then of course you're going to get decimals and fractions. So solve the system using substitution, and then use the graphing utility to verify. So I'm going to solve, okay? For most of us that don't love decimals, what can we do to get rid of them?
Make them whole numbers.
And how do you do that?
Multiply the whole thing by 10.
Good. So there's only one digit behind the decimal place in all of it, which means I can multiply by 10 to get rid of that. So this becomes 15x plus 8y equals 23. And this one, there's only one digit behind the decimal place, so I did the same thing, multiply by 10. You don't have to do this, but if you want to get rid of the decimals, it's easy to do so. Now here's a case where there's not a single variable by itself, right? So at some point I'm going to have to subtract and divide. So just pick a variable. Which one would you solve for? The y in second one? Okay. So I would subtract the 3x. This is negative 2y equals 1 minus 3x, and then divide by negative 2. So now I'm taking this and I'm plugging in here for the y. I get 15x. This would be 4. Negative 4 times negative 1 is minus 4. This would also be 4. 4 times 3, positive 12x. 27x equals 27. X equals 1. There's my first value. And then take them and plug them back in. So again, I've got options. I could plug it back into either of my original equations. The one I altered by multiplying by 10 because it didn't change the value, or even the one that I solved for y. Okay, this time it's probably not as easy to solve for it because you got fractions involved there, but it's a 1, so it's not a huge issue. I would probably have taken this one. So 3 times 1 minus 2y equals 1. Bradley.
The equation you solve for, you can just plug it back into that one as well, right?
Yep. Wait.
So like, let's say
Once you get x, you mean?
No, like, okay. So we solve for y, right?
We took the second equation and solved it for y.
Now if we plugged in that value into the original second equation.
Nope. You have to use the other one.
All right.
Yep. So now I've got 1, 1 as my answer. If this was an answer that was either fraction or decimal, you want to follow suit with whatever the question was. So if the question gave it to you in decimal format, you want to answer in decimal format. If it gave it to you in fraction, you want to answer in fraction format. Questions on that one? One.
So you don't have to like divide by 10 or whatever, it's just like how it works.
No, because you did the same change to the entire equation, right? So if you only do it to part of it, that's when you have to worry about converting it back at the end. But we didn't change the value of the equation because you multiplied everything by it. You just changed the format of it. Does that make sense? So I'll get it. As long as you do it to everything in that, and I would say that's the biggest mistake made is people change part of the equation and not the whole thing. You got to make sure you change the whole thing. And then again, you could take these and plug them back in. And we'll get to the graphing calculator in a minute, and I'll show you how you can plug them in. But you'd have to solve them both for y. So it's a little bit more work than it's worth sometimes. All right, so now we're going to solve by graphing. So this time you're going to graph each line or line in parabola or line in cubic function or line in square root function, whatever the graphs are. And where the lines intersect are going to be your solution. It might be once. It might be twice. It might be 3 times. It might not be at all. If they're lines and they're parallel, they never intersect. That means there's no solution. And if there's a line that overlaps, meaning you would have exactly the same line, then it would be all real numbers. So again, for graphing, you're either going to get 2 lines where they both be linear, or you can get a line and a parabola, or you can get a line and a circle, or you can get a line, or you can get a parabola and a circle. Okay, depending on the graphs themselves, you might have no solutions, 1 solution, 2 solutions, 3 solutions. Okay, it's going to vary. If there are 2 times where it hits, you're going to list both points individually of each other. All right, let's start with the lines. So it says solve this system by graphing. I know by looking at this, these are both lines, right? Because the x and the y's are both raised to the power of 1. And you've got options. You can graph the intercepts. You could plot points to whatever you want. My advice is probably get it in a slope-intercept format. It's probably the easiest thing to do. So I'm going to take this equation and solve it for y. So supposed to be negative 2y equals, minus 3x plus 7. And then divide both sides by negative 2. So y equals 3 halves x minus 7 halves, which I'm going to convert into a mixed number because it's going to be easier to graph. Fraction or decimal doesn't matter, but it's got to be a mixed number. That's the first one. And then I'm going to do the same thing to the second one. So negative 4y equals negative 6x plus 9. And then divide both sides by negative 4. 3 halves x minus 9/4. 3 halves x minus 2 1/4. So what can you tell me about those equations before I even graph them? Say again? They're parallel. How'd you know that?
They're the same slope.
Good. So same slope but different y-intercepts, right? If they had the same slope and the same y-intercept, what's true? Good, same line, all real numbers. But because there's the same slope but different y-intercepts, I know these are going to actually be parallel lines. So I'm going to zoom in and graph them. So I'll start with the bottom one, negative 2 1/4. And then 3 over 2. 1, 2, 3 over 2. Kayla.
So since they're parallel lines, wouldn't it be like no solution?
Yep.
Do you have to graph that?
If it says to just solve them and you catch it, then you don't have to. But if it says to graph it, 1, 2, 3.
Which one did you just graph?
The purple was the bottom one and the red one was the top one. So the graph should confirm what you think, which is that they're parallel, right? They don't overlap. They never touch. They're not going to intersect, which means there's no solution.
How do you put 2, 3? How do you have 3 halves?
Up 3 and over 2. So rise over run. And then we get to non-linear systems. How do I know it's nonlinear? The x is squared, which makes it a parabola. Okay, so the top one's a line. The bottom one's a parabola. So I'm going to do the same thing. I'm going to start with my line. I'm going to graph my line. So this would be negative y equals negative x minus 4. So y equals x plus 4. The more accurate you can be on these, the better off you're going to be at the end. So if I go to 4, and I go up 1 and over 1 as many times as you want so that you know that you can get a nice straight line. This is where your ID comes in handy. And then I'm going to graph my second one. So what I want to use is my transformations to at least get around about where it's going to be. So if I solve that for y, I get negative y equals negative x squared minus 2. So y equals x squared plus 2. So using transformations, what can you tell me about this shape and transformation? The parabola that's shifted up 2 places, right? So the only exact point I know from that, though, is this one. And then we usually estimate out the rest. So I still want you to do the same thing, except once you figure out where you think it's going to go, you want to get exact points. So it looks as though it's going to cross through negative 1, 3, right? Would you say that it's probably going to cross through there? Even if you approximate it, you think it's probably going to be around there. So to get an exact point there, I would plug in negative 1. So I'm going to make x equal to negative 1, and I would get y equals negative 1 squared plus 2. 1 plus 2, which is 3. So I know this point here is negative 1, 3, because both the x and both the purple parabola and the green line go through that.
Can't you just make a table?
Yep. It just, I mean, if it shifts to the right, you might not catch the table. If it shifts to the left, you might not catch the table. That's why I would do it at least a transformation to give you a roundabout, and then go from there.
All right.
Yep. And then it looks like it's happening somewhere. So I know I went out 1 up 1 over here, so I know it's going to have to be higher than that. So if I know this is 1, maybe I'm going to plug in 2. So if I do x equals 2, y equals 2 squared plus 2, which is 4 plus 2, which is 6. So 2, 1, 2, 3, 4, 5, 6. That parabola should actually be hitting that point there. And I know the green already passes through that point, so I know that's a solution for both. 2, 6. So then when I list my answers, I'm giving both 1, 3, and 2, 6. The order of those doesn't matter, obviously. Within the parentheses, it does.
Oh, you tested for 2 as well?
Yep, because you saw that it hit twice, right?
Wait, how'd you test for it?
How did I test?
Yeah.
Once you draw the approximate parabola, you want to hone in on what the points look like, where they might touch. So I would do an approximation. So I saw that it was like, looked like it was going to hit left, right? Usually parabolas, you go up and out 1 for the first jump, and then you have to figure out from there. But so once I knew it was going to hit here, I plugged in that point to make sure that I got the pink, I got that point from the purple or from the curve, and also saw that it was on the green line, so that's to know how it matched.
How did you know it was going to hit there?
I used my approximation for my transformation, so I guessed. I guess that's what was going to work, but then I plugged that value in for x, got the y, and saw that that was a point also on the green. So if it's on both, then it works. Everybody good so far?
So your answer would be negative 1 and 3.
And 2, 6. Yep, it's going to be both. If that curve, and I'm going to skip the next example for time, but I'll go back to it later. If this curve went up and down and up and down, every time it crosses that other green line, there's a solution. So in a case like that, that's 1, 2, 3. There would have been 3 answers. Okay? So you want to use your transformations and your knowledge of like where it should go to kind of hone in on plotting points, so you don't have to plot a whole bunch of points. But then you might get 1, you might get none. If this was a parabola that like was over here, that green line and that parabola were never going to overlap. That would have been a no solution. Okay? But you'll see that you could have no solution, one solution, two solutions, you could have a bunch. All right, this one says solve the system using substitution, and then use the graphing utility to verify your results, okay? So the first thing I'm going to do is solve it using the system, but notice again, this is not linear, which means I might get more than one answer. I want to go simplest that I can. So what's going to be, and there's not a huge difference here because they're both set equal to 0, but what would be one way to solve for one of the variables?
Bring over the y and the top of the equation.
Okay, so I could take this one and solve it for x. Notice it's the same, right? So x equals y means that in place of this x, I'm putting a y. How do I solve that? Take out a y and I get y squared minus 1 equals 0. Can I go any further? Good. Difference of 2 squares, y plus 1, y minus 1. And then I've got 3 separate terms. I set them each equal to 0. And I get y equals 0, y equals -1, and y equals +1. That means I have 3 coordinate points. God bless you. 3 sets of coordinate points. One where y is 0, one is -1, and one where y is 1. So now I've got to take and plug them each in here. Again, this one's kind of easy because if I plug 0 in for y, I get 0 for x. I plug 0 in for y, or -1 in for y, I get -1 for x. And if I plug 1 in for y, I get 1 for x. If there was work involved there, I would just plug them in and solve. With me so far? Then it says, use a graphing utility to verify your results. So what I have to do for each of these is solve them for y. Most of our calculators say y equals. Some of them allow you to change it, in which you could solve for x, okay? But on the bottom, that would get tricky because you're going to have to do the cube root. So most of the time, we're going to have to solve for y. So I know that y equals x, and I know that y would equal x to the third, because if I subtracted the x to the third, I'd have to multiply by -1 to get it there. And then I would use my graphing utility to type those two in and see where they cross. So I plotted those two, and you can see from my graph that the x cubed is my blue and the red is my line, and that they cross 1, 2, 3 places where it's -1, where it's 0 and 0, and where it's 1, 1. So when it says to verify, obviously you're doing just that. Solve your equation, figure out what your answers are, and then use your graphing utility to verify. Either the one on your calculator, on your iPad, or the one on your handheld. I don't care which one, okay? If it says to verify your answers using a graphing calculator, you don't have to pull in every question, okay? But if it says to graph and then answer questions based on the graph, you better give me the graph in your homework, because it's the only way you're going to know why you got things wrong if you got them wrong. This is how you utilize a graphing utility. So it says use a graphing utility to approximate all the points of intersection of the graphs graphs of the equations in the system, missing the word, round to 3 decimal places, and then verify by checking your results in the original system. So I want you to use your graphing calculators because that's what you're probably going to use. This is not a test in which you will get a graphing calculator the whole time. That is a promise, okay? If you do get a question like this, it would be something that's separated off, especially because matrices can all be solved on a graphing calculator, so this would be a very minimal part with if it happens. So I want you to graph those two equations. Go ahead and plot them in your y equals on your calculator. All right, so I obviously type them in, and then I'm gonna hit graph. This is what mine look like, okay? That's definitely a square root function and a line function, so hopefully that makes sense. Now to find the intersection, one option you have is the trace and literally go up and down your lines, but sometimes that's not 100% accurate. You also have that calc above the trace. So if I hit second calc, number 5 in that list is intersect. So if I hit 5, now it's gonna ask me questions. First curve, so is that line, is that tracer on my first curve? And the answer there is yes, right? It's somewhere on that first curve. So I hit enter. And then it's a second line. So this is my red line. Yes, that's the one I wanted to find. Oops.
So it's only at 2 different points in the view when you first.
As long as it's on your line. So this would happen if you, let's say you had 3 lines and you wanted to find where only 2 of them intersected. Then you would be honing in on just those 2. That's why it's asking you to identify it. So I think I lost my little cursor, but I think it's on there. Second curve. No, I didn't. There it is. Okay, it's on that yellow. It's on the red, so I know it's on the second curve. I hit enter again, and then it says guess. Hit enter and again, and it's going to bring you exactly to the point of intersection, which is 2.25 and 5.5. So that's my solution. Yep.
What do you do on the calculator again to get it to that?
Stop. So we won't do that last part to, again, save for time, but what would verify by checking your results in the original system mean? Plug it in, okay? I wouldn't expect you to know the square root of 2.25 off the top of your head. So if you had a graphing calculator for this part, you would use it for that as well. But you should get the same answer, okay? So you can use a graphing utility to check every question. Sometimes it's a lot of work because you got to solve them for y, and they're not always as obvious, okay? But if you were to do that, if you were to plug them in, you should get the same answer. If your homework says graph this on a graphing utility and then answer the questions, what do you have to do? Take a picture of your graph. So if it's on your handheld, that's fine, take a picture of it. If you're using the app, that's fine, take a picture of it. If it says solve it and use a graphing utility to verify, you don't need to bring in each individual picture. That's for you to check it. But if you're answering questions based on a graph, you better bring in the graph, okay? Otherwise, when I go over it, you're going to have no idea why you got it right or wrong because you don't know what your graph looks like anymore. All right, interest problems. So these are where the word problems come from for systems of equations. So one of them, or an example of a real world systems of equation, would be an interest problem. So if it is something like this where it says you're given the yearly interest earned from a total of $12,000 invested in 2 funds, paying the given rates of simple interest, write and solve a system of equations to find the amount invested at each rate. So a couple of things to pay attention to here. One, we're talking about simple interest. So this is just money times a rate. That's all simple interest is. Okay, you don't have to worry about PERT. You're not doing anything like that. It's not being compounded daily or anything. This is 1 year, 1 annual rate. So my interest equals the money times the percentage rate. Okay, that's what simple interest would be. The second thing is you're going to set up a system. So they're going to give you just enough information in which you're going to set up 2 equations. Okay, in the original part, it says that you have a total investment of $12,000. And then it says you had annual interest earned of $500. One rate was 3% and the second rate was 5%. In the question, it says write and solve a system of equations to find the amount invested at each rate. So what are my variables? What am I looking for?
You're looking for where they intercept.
Yeah. So I'll solve a system, right? Which I don't know if I'd graph it, but you could graph it or you could use substitution. But what does X and Y represent? Good. So X is the amount of money I invested. We're going to say this is the one at 3%. And we're going to say Y is the amount of money invested at 5%. So when I get my overall answers and I get my X's and my Y's, I know X is the 3%, Y is the 5%. So annual interest earns means that whatever money I invested at the 3% times 3%, so 3% times X, plus whatever money I invested at the 5% or 5% times Y equals the total interest earned, which is what? That's the amount invested. How much is earned? 500, okay? So that 12,000 comes back into play into what? I know that the total money invested into both is 1,200. Good. So X plus Y equals 1,200 or 12,000. They will always give you some sort of relationship there. It could be that you invest double the amount in X as you do Y. And so you would say x equals 2 times y. You don't have a total overall amount there. It could say something like this where it says that you have a total amount earned. It could say you invested 2,000 more in x than you did in y. So then you would have y equals 2,000 more in x. So you would have x equals y plus 2,000, something like that. Okay, so there's always going to be some sort of relationship. But I've already set up a system. Now I got to solve it. Can I leave 3% as 3%? What do I have to change it to? Good. So this is 0.03x plus 0.05y equals 500. Tomorrow, once we get an elimination, you might choose to do elimination here, but for right now, we're pretending we don't know it yet. We haven't reviewed it yet, so we're going to do substitution. My advice is get rid of your decimals first. This time I have to multiply by 100 because I have to move that decimal twice. Biggest mistake made in this question on a quiz or a test is not moving the decimal on the other side of the equal sign. Most common mistake, so be careful. So now I've got that, and x plus y equals 12,000. And there's my new system. This time not so bad to solve. I can solve like for y equals 12,000 minus x, and then take that, plug it in up there.
So you don't have to multiply the other one by 100?
Nope. You're only changing one. As long as you change the whole thing all the way across, you don't have to change both.
Are you gonna have to divide after?
Nope. Because you change the whole thing. So only if you change one part of the unit and not the other. So I'd get negative.
So to get rid of the decimals, you wouldn't have to multiply the bottom one as well.
Nope, because you're just changing one full equation. As long as you change the entire equation on the left side and the right side, you're not changing the value, right? It's still the same thing because you changed both sides.
Okay.
You kept it balanced. Oh, this should be negative. So x is 5,000. And we said x represented which account? 3%. So if I'm saying already that I invested $5,000 at 3%, how much did I invest at 5%? Mm-hmm. What was my total investment? $12,000, right?
Yeah.
So that means $7,000 at 5%. So these won't be written in coordinate point form. You're going to give them to you like a real world answer, okay?
Wait, so how do you determine like the 3% and the 5%? How did you know which one's
It wouldn't have mattered, but it's whatever you establish. So we said x was 3%, y was 5%. If we had switched those, then we would have known at the end whatever we solved for, because we solved for x first. I knew that that was my 3%, and then the y would have been my 5%. This next example is a break-even analysis. So if you think about the real-world application on this, break-even is when you stop losing money and start making money. So if you are setting up the sales for something, in this case, they gave you the cost function and the revenue function. So this is basically saying there was some sort of like an initial setup fee of $250,000, and whatever they're making cost $8,650 per item to make. And they can sell it for $9,950 per item. So the break-even point is when the revenue equals the cost. So technically this is a system because if you look at the breakdown of it, this is two equations with two variables. The difference is that this variable is different from this variable, but we want them to be the same. So we want to know where 8,650x plus 250,000 equals 9,950. So then I just solve. So I would subtract 8,650 and then divide by 1,300. So what am I at? 2,500 divided by 13, which is 192.3. So that's your exact break-even point. So you got to look at the wording on the question. If it asks with the break even point, that's your answer. If it says, how many units would you need to sell in order to break even? If I round this to the nearest whole unit, it goes to 192. But 192 means I haven't broken even yet, which means if I'm trying to find out how many items I'd need to sell in order to break even, I'm actually going to round up, never round down, because down means you lose the money. So I, in that case, would answer as 193 units. So this is my break-even point, but this is how many units I would need to sell in order to break even. This goes back to geometry, okay? Perimeter. So you're going to set up a system based on the perimeter, and again, I'll work these out on the video, and then solve it. So there's a lot of word problems in dealing with systems of equation. This last question is system word problem involving length, or in this case, perimeter. So it says the perimeter of a rectangle is 30 meters, and the length is 3 meters greater than the width. So if I want to get a visual on this, I would draw myself a rectangle, and it says that the length is 3 meters greater than the width. So I'm setting up a system. You can actually do this without a system. I can say that if this is the width, then the length would be the width plus 3. And because perimeter equals twice the length plus twice the width, 30 would equal 2 times, this is my length, W plus 3, plus 2 times W, because that's my width. And then I can solve it from there. But because this says, or it says to find the dimensions using a systems of equation, we're actually going to set it up as though it's two different systems. So the perimeter is still 30. This would still be 30 equals 2L plus 2W. But then instead of writing the length already in terms of the width, we're going to say that the length equals the width plus 3. And then here's our system. So this would be my systems of equation that I'm going to use. And then the next step is where we just were. Take this and plug it in for the length. So from there, I would get that 30 equals 2 times W plus 3 plus 2W, distribute the 2 to both the W and the 3. Subtract the 6 and divide by 4. So if the width is 6 and the length is the width plus 3, then the length would be 6 plus 3, which is 9. So when I find the dimensions of this rectangle, it would be 6 meters by 9 meters. So you'll see a lot of different types of examples dealing with length or area or perimeter in this case. But just make sure that if it asks you that you set up the system and then solve it from there.